Assalamualaikum and hi, my name is Sharifah Nur Hazika Alia binti Wan Masri. My number matric B1324107333. Today our group will present pin on this wear experiment for Bmkm 2323 basic tribology. Tribology is the study of friction, wear and lubrication between surfaces in relative motion. In this experiment, a stationary pin is pressed against a rotating disc to study the friction and wear behavior under different operating conditions. This experiment is important because friction and wear affect the efficiency, reliability, and lifespan of mechanical components such as gear, bearing, and machine parts. The aim of this experiment is to understand how factors such as load, speed, material, type and lubrication influence friction and wear performance. Now I would like to pass the presentation to the next presenter. Thank you.
The poster highlights four main objectives of this experiment. First, to investigate the relationship between friction force and load. Second, to examine the relationship between friction force and sliding speed. Third, to study the relationship between wear rate and applied load. And next, to analyze the effect of different material combination on friction and wear behavior. This objective helps us understand how operating conditions influence the performance of engineering materials and lubricated systems. Next, I will hand over the next presenter to explain the experimental setup.
Hello, my name is Wanur Ashraf Hakimi bin Wan Mansur and my metric number is B1324100675. The experiment was carried out using a pin on this apparatus. The pin material used was stainless steel with a diameter of 6 mm, while the disc material was EN24 steel with a diameter of 100 mm. SAE40 engine oil was used as the lubricant. The test was conducted at a constant speed of 200 rpm with loads ranging from 10 Newton to 50 Newton, increasing in intervals of 10 Newton. Each test was conducted for 10 minutes. The apparatus consists of several main parts, including the load, pin holder, pin, rotating disc, disc shaft, and motor. During operation, the pin is pressed against the rotating disc and the friction force generated is measured. Next, we will discuss the factors affecting wear and friction.
Assalamualaikum and hi, my name is Hani dari Natasha binti Sani with my metric number B1324100729 and I will present factors affecting wear and friction. According to the poster, there are four major factors affecting friction and wear. The first factor is load. Higher loads increase the contact area between surfaces, resulting in higher friction force and wear rate. The second factor is material selection. Harder materials generally experience lower wear, although they may sometimes produce higher friction. The third factor is sliding speed. Increasing speed may reduce friction due to the improved lubrication, but it can also increase temperature. The final factor is lubrication. Proper lubrication creates a protective film between surfaces, reducing direct contact and minimizing friction and wear. The poster also introduces this try-back curve, which shows the relationship between the coefficient of friction and lubrication conditions. As lubrication improves, friction generally decreases. Now I will pass the presentation to our final presenter. Thank you.
Okay, my name is Nur Fatia binti Rizal and my metric number B1324100227. Okay, I will explain the conclusion. Based on the key observation shown in the poster, friction force generally increased as the applied load increased. It was also observed that friction force tend to decrease with increasing sliding speed after reach a certain operating condition. In addition,
Wear rate increase under higher load because greater contact pressure exists between the surface. Different material combination also produce different friction coefficient and wear rates. In conclusion, this experiment demonstrates that load, speed, material properties, and lubrication all play important roles in determining friction and wear performance. Understanding this factor helps engineers design more efficient and reliable mechanical system while reducing component failure and maintenance costs.